till 6 p.m. and then we can start. So
Yes,
otherwise,
yes,
yeah,
yes, that is correct.
yeah. So hello, Rana. I'm Prashant.
Hello, Prashant.
So what are you doing?
I am in MCA final year
Okay, okay, okay. From?
from
Uh,
Techno India University. And you?
okay, okay. So also little bit more about me. So I am an aerospace engineer at IIT Kanpur, and I work in machine learning and science as well. So that's where I work in the interdisciplinary area. So that's why I am teaching in this course. Uh,
It's my
yeah,
first online class and first class in deep learning also. So I am very excited to know about it.
yeah. So yeah. So a question like, have you watched the lecture, or
No, I
you still
haven't.
have to
My
watch?
semester is going on. That's why.
Okay, okay, okay. No problem. I will try to explain everything in detail. Yeah.
That would be very helpful. Thank you. So Prashant, you are from IIT Kanpur, right?
Yes.
But you are teaching a course of IIT Kharagpur, I guess. It's affiliated by
Yes.
IIT Kharagpur.
Yes. Yes. So basically, I am a PMRFS scholar. If you know about Prime Minister Research Fellowship.
Yes,
So
sir. I know
basically,
about.
those who are the scholars, PMRFS scholars, they have to teach each year some hours. So basically, we teach in these online courses, and so this basically fulfills our criteria for PMR being a PMRFS scholar. At the same time, we try to enrich people with our knowledge, and we try to share and we ask questions so that we can learn as well. We can improve our teaching because we are a student at now. So once we will be a professor or anything, we will know how to articulate our thoughts in a better way in the later part of our life. So that's why we are teaching these tutorial courses. Yeah.
Right. I was also looking for some research internship, and then I came across this course. People suggest me that you should do it.
Yeah. No worry, you should watch the lectures and ask as much as question you should as much as possible, and
Yes,
I
I
will
will try
try
to
to.
grasp all of it.
Yeah, yeah. Just a minute. Yeah. Yeah. Let's wait.
Yes, Prashant ji,
Yes, sir.
you can see my video. I switched on the light now opposite to my face. Previously, light was that side.
Yes, there's some kind of refraction was there.
Yeah,
Yes.
light should fall on the face. Then only you
Yes.
can see. So it was light was that side. Now I switched on this light as well. And that light, if I switch off, I can see. I'm not well. That is why I'm switching my phone off. I'm
Yeah,
getting
yeah,
cough.
it's fine. Once you will have a question, you can ask the question. Otherwise, it's fine. Yeah. So I think it's already. Let me check if it is getting recorded or not. Yeah, it's getting recorded. Yes. So yes, I will start again. So I am Prashant. I am a PhD scholar at IIT Kanpur. Uh, I work in aerospace department. So this is the third week. So I will try to explain the support vector machine, the idea of support vector machine. So from where it came. So earlier last week, what we were discussing, like let's say if we have two classes and we were trying to classify those classes, like we were trying to create a boundary. That boundary will tell like on which side of the boundary the which class exists. So we were trying to create a linear classifier in a way that uh, just a minute. Yeah. So the idea was like, let's say I have two features such as x1 and x2, and those two feature represents
Yeah, we are not
two
seeing
classes.
your screen. We are not seeing.
Uh, Anyone else?
Screen sharing, I think you need to do it.
It's visible. It's visible.
Visible.
Uh,
Maybe I have not clicked
I
something.
think, yeah, please try to pin my screen and then you will be able to see
Okay.
my. Okay. So basically, if you have two classes, W1 and W2, and then you are trying to create a boundary such that, okay, I'm joining. I think I should wait another 2 minutes. Yeah,
Yeah,
please wait.
I am seeing your screen. Okay,
Yeah.
great.
Yeah. So yeah, let's start. So basically, we were trying to create a boundary, and the boundary can be this, a boundary can be this, a boundary can be this. So idea was like if you have watched the lecture of week 2, the professor told like if you are trying to negate this, and then you are saying that if I have a classifying line, we are calling this as A transpose X plus B is equal to 0, such that for W2, A transpose X plus B will be less than 0, and for W1, A transpose X plus B will be greater than 0. However, we want that if you are trying to get the value of A and B, we are saying that for all the training data consists that lies for W1 and W2, the value of A transpose X plus B should always be greater than 0. In that case, we will be able to create a formulation to find the loss function, and then we will able to train that. So it means that we are just trying to negate it in a way that these numbers, these training points or this class will come somewhere here. Let's create the green one. Yeah. Right. And then we are saying that this A actually tells about this normal vector to the line such that if we have the different lines here, then it will tell about the area in which we can have a different line. So like, let's say if I have this line, then the normal vector will look something like this. If this is this, then this will go something like this, right? If something comes like this, then normal vector will look something like this. So basically, if you will take all these lines to a point, they shift it to a point, then you will create uh, this range of areas in which a multiple solution can exist, right? When you try to train these values of A and B anywhere, if the solution lies here, then also these criteria get fulfilled. If the solution lies here, this criteria gets fulfilled. However, you want the solution that creates the maximum margin between those two classes such that you only get one solution, and that one solution should be the most accurate one. Okay, so let me create the another uh, graph in which I'm saying that I have class 1, I have class 2, and then I'm saying that there is a common line that passes between those two classes such that A transpose X plus B equal to 0. However, I'm saying that this margin, let's create another point here. This margin, that distance D is maximum from this classifying line, the line that is dividing the two classes. So basically, we are currently talking about the linear classifier and the linear classifier with the two classes. So simplest case. Okay. So we are saying that here the A transpose X plus B is equal to plus D, and here A transpose X plus B is equal to minus D. So this is below this line, so we are calling this as a minus D because this is a parallel line, and when you are creating a parallel line, basically you are changing the intercept. The intercept is a B. So we are basically you are adding and subtracting the intercept. So, and if you will say that the distance between these are 2D, that should be equal to, let's talk a little bit about the D. The D would be equal to, let's say I have a point here, X plus, and I have a point here, X minus on this line, then that distance will be A transpose X plus B mod by mod of A, right? So that's how you find the distance, the normal distance. And let's call it as a D plus. Similarly, you can calculate the D minus, and we are saying that this line is in the middle. So D minus will also be equal A transpose X minus plus B mod by mod of A. Right. Okay. So the total distance will be D minus D plus minus D minus, and basically you can add these 2 points, 2 lines. I mean, that is the total distance, that is 2D, is actually this is 2 times of A transpose X. I mean, you can write like this, since A transpose X plus minus X minus right. Yeah. So D will be A transpose X plus minus X minus. Okay. So this comes when we are not normalizing, we are saying that the margin, actually this margin is D. So when we will normalize everything, like let's say if you are normalizing this by D, then this will become actually, this will become 1. Okay. In that case, you can write this as a 1 by under root 2A. Now, so now we are saying that now let's say for these 2 classes, we are able to create a boundary in which I would have a maximum margin between the 2 classes such that I would be able to classify for any new data in the most accurate way. Okay. Now let's talk a little bit like this. This came the theory part. Now let's talk a little bit more mathematics, like uh, in a way that mm, you could able to create the more picture, the more mental picture of this, such that you like this is what we are assuming if we have the solution. We are assuming that when I know the A is correct, whatever the value of A is correct, but how we will find the value of A? So we are saying that I want to get this value of A in a most accurate way. In that way, I will have to maximize the value of D. That means I will have to minimize the value of A, right? Okay, sorry, this is 2. Yeah, so I will have to minimize the value of A. And when you want to minimize the value of A, what you do? You basically you convert into some kind of quadratic function, and then you say that if I will minimize, I mean basically you are minimizing the value. So basically you have a optimization problem where you say that I have to minimize the value of A. But when you are doing some kind of minimization or the maximization problem, you convert that problem into some kind of a quadratic problem. And in that case, I will say that instead of minimizing the value of A, I will minimize the value of A square by 2. Why 2? It's just a mathematical way to make the mathematics easier. You can write the minimization of A square because for for any y equal to x square that looks something like this, you can get the minimization here, right? So like if you want find the minima, you can come to the minima like so. So this actually looks like the way something, let's like k is equal to minimum of A square. Just a minute. Right. Now, so we want to minimize the A given the condition that A transpose X plus B is always greater than 1. Right? So if you want to minimize the A given this condition, you can create a Lagrangian multiplier, and then you are saying that for given all the values of X, you create a multiplier alpha with A transpose X plus B minus 1 for all the value of alpha. Let's call it as X for right now, the capital X. Okay. Now, this is also some kind of a vector for right now. If you are converting into the indicial notation, you will write that my problem is the minimization of A such that we have the problem A square plus sum of all alpha I A into xi. I mean, you can write A as a vector ai xi plus v minus 1, right? For all x, for all xi, right? Like if you have a 20 training points, you can have a 20 xi. In this case, these the xi belongs to w1 and w2. Okay. So the number of training point you will have, that will be the xi. And the yi will be whatever you are saying, like if yi will be like if it is plus 1, it belongs to omega 1, and if it is minus 1, it belongs to omega 2. Okay. Okay. So this is what we are trying to solve it. Okay. Whenever you are trying to solve any minimization problem, what you do? You try to take the derivative with whatever you are trying to minimize, right? You are trying to find the value of A and B such that this would become the minimum, right? So we are writing this as a y is equal to, or let's write for the k is equal to, or some L, let's write L. So let's write this as L. So we are trying to minimize this function given this alpha, right? Like I don't know the value of alpha, but let's say I have some value of alpha, then we are trying to minimize the value of L. And so if you know the alpha, what you are trying to optimize? The value of A and B such that the distance is optimum between the two classes such that you will get the optimum margin for the classifying line, right? So what you can do, you can write the dou L by dou A, and that would be, let's write the 2 for the making the mathematics easier. So you will get the 2A and the 2 we cancel. So we will write A plus, it will become alpha I xi, right? And then what I will have by multiplying with this, and then this will be gone, this will be gone, right? And then you will take the dou L by dou B, then this will be gone. So you will have a you have a alpha I. Okay, there's one more thing I forgot to write. So we are saying that here I have written. Okay. So I have told that this will be always greater than 1 in the case that I am saying that yi into A transpose xi, I mean ai xi plus b is always greater than 1. So I have to write the value of y as well here. Okay. So I mean, I told this mod, that is also correct, but to create an optimization problem, we are making use of whatever the solution I have that is the y. Okay, so let's y here as well. In that case, this will become yi and this will become yi. Okay, and we are saying that wherever I will have the minimum L, that's where that will be the 0, right? For all the alpha I greater than 0. So my Lagrange multiplier is always positive. Okay, so that is the basic optimization criteria. Okay, just a minute. Yeah. Yeah. Now, if you will put this term here, what you will get? So now you have like A is equal to minus of sigma alpha I xi yi and alpha I yi is equal to 0 sigma here. So if you will try to keep in the L function, this will become, if you'll put here, in this case here, then it will become sum of, since we have a square, we have to write it in the 2 times. And when you are writing the summations 2 times for the same thing, you will change the indices. You cannot write like for all I. Here I have given the I, so I will have to create another index called, and we will call it as j. So I and j, and this will become alpha I, alpha j, yj into xi into xj plus, if I will write the value of here, let's what we have in this case alpha I yi, write it smaller, so it will become sum of alpha I yi, and then what we have to put? We have to put the value of a here. Sorry, so yeah, value of the a here. So a is basically minus summation of alpha I xi yi. Let me check if I'm going right. Just a minute, otherwise it will create problem later. I hope so. Let's. So we are minimizing the value of a, that is here, this one, and we are maximizing the value of alpha. So let's erase this one for now. So we are minimizing the value of a, okay, for all the alpha greater than 0. So this is the primal problem. So what this is called? This is called the primal problem. Okay, we are assuming that we know the value of alpha and we are trying to find the value of a and b. Okay. However, this alpha is a hyperparameter In that case, we have to maximize the value of alpha as well. So basically, we have to do the two optimization. So basically, we are calling it as a dual problem. Okay. Not sure that this is correct. Hmm. Yeah. Anyone? Have you watched the lecture? I'm not getting any response from anyone. Are you there? Okay.
Yes.
Yeah.
We are there.
So have you understood what it mean by the primal problem and the dual problem? So the primal problem I told, like, we are trying to minimize the value of A such that we get the maximum margin. At the same time, we are trying to maximize the value of alpha such that, so wherever the support vector in this case, like, so when we are using the word support vector, we also need to understand that, like, let's say we are trying to create this margin. So basically, in this case, these 3 points are taking participate in creating this margin. So for this uh, points, I will have some alpha, and here the alpha value will be 0. Eh, Later we will know that. So that's why we are saying these points as a support vectors. Okay, that's from where the name came from, the support vector machine. Okay, so when we are trying to solve the value of alpha, we are trying to maximize the value. We want to maximize the value of alpha for these points, and for the other point, the value of alpha will be 0. Okay. Yeah. In that case, we will write this dual problem for maximizing the alpha. We will write this as a max of L of alpha. That is the function of alpha itself. That will look like sum of all the alpha I minus half of this. Half is coming from here. That is alpha I, alpha j, yi, yj, and xi, xj. Now, if you see this yi and yj, let me write the two summations here, are the outputs that you know. Xi and xj are the inputs, right? And we are trying to find the value of alpha I or the alpha j. So basically, alpha xi into xj is telling, like, when you do any dot multiplication, you multiply the same thing with itself. We are trying to find the similarity index, right? So this xi and xj, if it will have a value greater than 1 or it has some positive value, you are saying that it has some similarity. If it is 0, then we are saying that they are not participating in finding the value of alpha, right? So basically here, these xi and this xj, if they are getting multiplied, and then they will produce the value of alpha I and alpha j as 0. Okay. For alpha I always greater than 0. Okay. So this is what we are trying to solve it. Now, this is the basic problem that you can solve it simply by taking the differentiation. So idea is like, Since you have taken the differentiation, you got the value of A and B. You put the value of A and B here, and then you got the equation for alpha, and you are trying to maximize the value of alpha. Once you get the value of alpha, you put the value of alpha here, and then you will get the value of A and B, right? So that is the dual problem. So this is what it has been discussed initially in the lecture. Then professor talked about the multiple class support vector machine. And before that, he talked about the linear classification for the multiple classes. Okay. So now let's talk a little bit about the linear classification of the multiple classes. And in for the multiple classes, as well as for each class, you have the more than one feature vector or more than two feature vector. In a sense that, let's say, uh, if you have any image of pixel size 32 cross 32, then it will have a RGB if it is colorful image, RGB pixels. Okay, so basically it will have a data of 32 cross 32 into 3, and this data goes from 0 to 255 in each pixel. So basically you have an image. Let's call it as a gray image for now. Then you will have a 32 cross 32 vector, and you are calling it as a pixel. Okay, and then for each pixel you have some number that goes from 0 to 255. Either you can normalize it by the maximum value. Okay. I will not accept any more people, I guess. Yeah. And then you can do the numbers between 0 to 1 for the easier computation. Now, you are saying that one image has 1, 0, 2, 4 features because each pixel has something. Now, let's say you have a 50,000 such images, and those 50,000 such images tells about the 10 different classes. So some image consists of some different animal, another image consists of some other bird, such that overall these 50,000 points, 50,000 images contains 10 different type of, let's say, species. That means you have 10 different classes, you have 50,000 inputs, and for 50,000, for each input, you have 1024 feature vector, right? In the case of gray image. If you have a colorful image, then you have a pixel for red, you have a pixel for green, you have a pixel for hello. Yeah. Am I audible?
Yes.
Anyone?
Yes.
Yeah.
Yes.
Okay. Yeah. Okay. Okay. So basically, we are saying that we are creating a function that is mapping from r to the power d, that is 3072, to r to the power k, that is 10. Okay. So we are trying to create this feature mapping between input to the output, in which I will have a d-dimensional feature of 3072, and I will have a n number of such input. So n is basically 50,000 here. And then I will try to classify those 50,000 points into 10 different kind of classes. Okay. So if you are remembering the previous classifying problem where professor assumed that in each class the variance is the same, in that way we were getting this value of G as a W transpose X plus W naught, right? Let's not worry about the distribution of each classes for right now. Let's assume that the distribution of each are statistically same. Okay, so means each of them has the same variance. In that case, we are saying that the classifier will look something like this. However, this W will be a matrix now, and this will be a vector. In that case, this W will have a dimension of K cross D, and this X will have a dimension of D cross 1 if we have a one input, let's say. And in this case, it will be 3072 cross 1. That means it will be a vector. And we have a W naught that has a dimension of K cross 1. Okay. For each classes, I will have a one intercept. Okay. Understandable? Anyone? It's like you are trying to create suddenly I moved from a simple explanation to a matrix explanation. So I hope you are understanding what I am talking about. So basically, when you are trying to multiply W with X, so X has a D factor. So for D features, so for each features you will have a one W, right? So basically you are saying that W1 1 into X1 plus W1 2 into X2 until W1 D into XD. Let's go. Plus W naught. Okay. 1. Let's call it 1. Right. And similarly, you will do for all these X. So let's call this as a X1, capital X. In this case, this capital X will have an element of 50,000, right? And then we have the D number of feature. So for each 50,000 feature, and this will become W transpose X plus W naught. That will look like K cross D into D cross N plus K cross N, right? So you have an intercept for all those numbers, all those inputs, and this will become K cross N, right? And then it can be added. In this case, and that is actually equal to your original solution, right? So let's say so when you are trying to say that if I am giving some input xi such that W transpose xi plus W naught is some output, and if xi belongs to the yi, then this yi component, I mean, let's call it as yj in the sense that j goes from 1 to k. Then this j component, like we already know that if this W is trend, means W is correct, we know that this W is classifying correctly this input output, then the this like I will have a 10 output, then the jth output should be the maximum value. Okay, and then we will saying that okay, if this is the maximum value, then this W is correct enough to classify my input and output. Okay. If this is if this is not giving the correct value, then basically we will be saying that whatever the error I am getting, like let's say if I am getting the value of yj as some value, let's some c, and actually I should get some value k, then I am saying that this is my error, and that error should, if I am training this value w and w naught, and if that error is less than some gamma, then I will say that this trend W is predicting the correct value. Am I right? Anyone? Any confusion? So C is my whatever I am getting from here, and this is what I should get. And we are saying that if that difference should be less than gamma, then we are saying that my W and W naught is trend. Okay. And this gamma will act as a margin such that we are saying that if the margin is less than gamma for all this training, then then the W is trend. Otherwise, this will act as an error, and that will considered for the loss calculation of the loss, right? Anyone? Anything? Okay. Now, so now I have created this G function that tells the score why that like this score is okay. Make it smaller. Yeah. So basically, let's call it as a score. So we are saying that this score decides the yj is correct or not. So if we are saying that this score, whatever we are getting here for j, that is going from 1 to k, that is a function of input and this weight and W naught, right? And you can call this as a convert this into a 1W as well. Like you have to just include one extra vector into this W, and this will become a combination of intercept as well, right? So basically, if you are writing ax plus b, so basically you can write this as a comma b into x comma 1, right? Or you can write this as a comma transpose x plus b. So ideally it will look like this. So you just want to add this b as inside this. So you can add one uh, extra column, and one extra row will be added into the x. Okay. Okay. Now, so now I have created a score function deciding that it will take some input. It has some W and it will decide the score function. And if a score function is less than some margin, then we are saying that we don't want to include that into the loss. And if it's greater than some margin, then we will include that into the loss. So we are saying that for any sy that is not j, and if we are finding the difference, and if it is greater than or equal to some gamma, right, then that will be part of the loss function. And in that case, I will write loss function as sum of all j not equal to yi, and I will write max of 0, comma, sj minus syi minus sj plus delta. Okay. So now this loss function is called the hinge loss function. Okay. So why it is called hinge? Because it has some limit, and the limit is this value. If it is, if the loss is, if this difference is greater than delta, then this will be considered as a part of loss function. Otherwise, it will be 0. Right? Understood? Also, now since we are trying for this, we are trying to train the value of w, and we are initializing some random w, and then we are saying that once we are trying to train the value of w such that this loss would be minimum, I can have a many w's that will satisfy this condition, right? Like in that case, we are saying that we want to minimize the value of w as well, such that at the end I should get one value. In that case, I will add the regularizer for the W as well, such that whatever the W matrix I am getting, that should be also be the minimum. Okay. Anyone? Any question? Hello. There are quite number of people here. So we are 12 people. Anyone? Any question? I mean, if you will not ask the question, I won't be able to teach you whatever you wanted. Okay. So please
Yeah,
ask question.
yeah, what is regularization? What is that you are regularizing?
Yes, exactly. So, yeah. So regularization is something that itself minimizes to a value that does not change every time you train. So, like, let's say you are saying that, let's take some simple example. Yeah. So here, in this case, let's write this a simple y equal to ax plus b. Okay. And we are saying that for some value of a and b, for given input x, it should always be greater than 0. Okay. For all the given input x, this combination should always give the value greater than 0. A simplest example. Okay. So if I am giving some input, I can have a multiple sets of a and b that will give the value greater than 0. Okay, like I have a set of 1, 2. Let's take, I can have another set 3, 4. Or let's give the input x is equal to let's 3, 5, 6, or any x. So this a b, this ab, all of them are producing this greater than 0, right? Or given the input x3. It doesn't mean that you want all of them, right? So you want the minimum value of a and b such that for given input x, this is always greater than 0. Okay. That's when we will write a regularizer such that we want to minimize the value of A and B. So I will have some minimization problem here plus some regularizer that was a function of A comma B. Okay. So we are trying to minimize the value of y given that the A and B should be the minimum. Okay. I think I answered your question.
Yes.
Right?
So it's like Lagrangian optimization problem, right?
Yeah,
There also
it's
you
not
have like this.
given in Lagrangian optimization, you don't know the value of lambda.
Yes.
Right. Here
Yes.
you give some small value. You assume that you know the lambda. Lambda is a hyperparameter.
Okay.
So this is not a Lagrangian problem anymore. Okay.
Okay. Okay.
Yes. Anyone? I mean, that would be really good. Yes. So this is what the simple thing that is are there in this week. I mean, you can learn as many as things you want, but I mean, I think I have passed the topics very fast, I guess. So let's talk some very decent things in a more simpler way. So I'm not sure all of you understand the linear algebra in this way, like whatever I explained here. So yeah, let me ask some question. So can anyone answer what does it mean by the features? Anyone? So I would know what I have to discuss more.
It can be described as the quality of a certain object, that's called a feature, so that we can identify a specific object.
Yeah, I mean, let's. Can you be more scientific? I mean, let's say we are discussing it here. Like, let's when I am talking about you, I have a picture of yours. So then I can talk the features like your color, your hairstyle, your nose, your ears. These are the features of yours, right? So when I want to describe you, I will describe all these things as a feature, right? Similarly, if I have to describe between a image and another image, I will take these features into the account and will say if this image has two ears and a nose and it has two eyes above the nose and they are in a certain triangular fashion, this might be a person, right? So that is a description of a feature, and that is what my algorithm will learn, right? So yes, and what is this class? I mean, where I mean, talking the class is a nonsense kind of thing. But yeah, understanding the feature is most important thing. Like whenever you have some input, you have same data, and someone wants you to say that okay, I have given you some data. Try to create an algorithm, and then I will give you some data, and you have to predict that data belongs to which class. Like if I am giving you some uh, 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 electrode, you can say what is it, MRI. Let's say I am giving you some MRI of some patients, and then you are trying to learn those MRIs using some machine learning algorithm, and then a person comes with a new MRI, and doctor check that MRI through your algorithm, and he should be able to figure out what is wrong in that and what kind of illness the patient is facing, right? So to describe those MRI, you will have to create the features across those MRI. Like, okay, if this has certain number of pattern, then this contains this kind of illness, right? So that we have talked in the first week, I guess, right? So you already solved those questions. So also, there is another question. What do you understood by the support vector? So why we are naming this as a support vector machine? Anyone? Yeah, actually talked about the support vector. So like you have two classes. What happened? Yeah. I have two classes here and here, but when I am trying to create the maximum margin between those two classes, these are actually participating, and for these points or for these vectors, the value of alpha is greater than 0. However, the value of alpha is 0 for all the points who are not participating in while creating the margin. So these are the support vectors. That's why we call this as a support vector machine. Okay. Yes, that is the one question I need to ask. Yeah. What is the primal problem and what is the dual problem? Anyone? Anyone want to answer the primal and dual problem? What does it mean by that? So primal problem is like you only have to minimize something or maximize something. If you have to minimize as well as maximize, then you are getting a dual problem. And you cannot do that both at a time. So basically you will solve one part, you will get the data from there, you will get the solution from there, you will insert into the maximization problem and you will maximize that. So that is a dual problem. And that is what the support vector machine is doing. Because you are getting a Lagrangian multiplier that are the alphas, that is also the support vectors. So the support, you can say coefficients for the support vectors are always greater than 0, not 0, right? Okay, so let's solve some problem. Let me come here and stop sharing this. Are you able to see my screen?
Yes, yes.
I think, yeah. So these are the questions from the previous year. On the previous year, that's when this course was circulated. So I mean, you can say it was there on the year. So let's solve these questions. And if you have doubt, and through these questions, we will see if you have any doubt. So you have a point in a 3D, you have a 3D point, and that is called XYZ. and you have to find the distance from a plane that is given by 2x plus 2y plus 5z plus 9 equal to 0. So how you will solve that? Anyone? I would like to get the answers from you. So that would be much better.
Substitute these coordinates -3, 1, 3 in place of x by z in this expression left side and divide
Yes.
it by square root of 2 square plus 2 square plus 5 square.
Yes,
You will
so
get
that
the
would be the
distance.
normal distance from the point P, right? Exactly.
Yes.
Yeah. Thank you. So you can see this is the answer. Correct. Yeah. So now this is the question second. So what shape of loss landscape during the optimization of support vector machine? So if you remember, I was trying to create a function that had some square, and I was saying like, okay, if I want to create a optimization problem, I should create, because there I was trying to find the minimum value of A in a way that I had the classifier line that is A transpose X plus B, in a way that if I want the, I had to maximize the margin, I had to minimize the value of A. So I was creating a square as a loss function with the Lagrangian multiplier. So that A square is a which kind of function? For like L equal to Ka square, yeah, Y equal to C Ax square. So these are the parabola, right?
Parabola, yes.
So we are creating these parabola are the convex functions. Okay, I will talk a little bit about the convex function later after we complete this. Okay, so yeah. So how many local minimum will be encountered while solving the optimization of maximizing the margin of support vector machine? So yes, so question is how many local minimum will be encountered while solving the optimization of maximizing the margin of support vector machine? Anyone? 1 to infinity 0. It would be infinity or 0 or 1. Anyone? So why we are studying the support vector machine, that itself gives the answer.
I guess it's 2.
Why 2? I mean, can you explain? Let's see your explanation. I mean, guessing is not the right thing. If you remember, the idea of support vector machine came because when you are trying to create a classifier between two classes, you can have an infinite number of A vector between some range, right? And you don't want all those solutions. You want a solution that creates a maximum margin between those two classes, and that margin should be such that if you are giving any new input, it would, if it produces the value greater than 0, then it is in W1, or it is producing less than 0, then it is W2. So the idea of support vector machine came from getting one solution, and that solution is getting the maximum value of D, the maximum value of margin, right? Am I correct?
Yes, that which gives least error you want to find. So that
Yes.
is one.
So that is the one, right?
Yes.
Yeah, answer is 1. So basically, the explanation is in SVM, the objective is to find the maximum margin, right? That we're explaining right now. And for the maximum margin condition to be satisfied, we have to minimize the value of W, and we will get the one global solution. There will be only one value of maximum margin, right? You can't have more than one value. The question is, which of the following classifier can be replaced by linear SVM? Logistic regression, neural network, decision trees, none of the above. So if you remember the logistic regression, what was the logistic regression? The logistic regression itself is a classification problem. And that classification, even the decision tree is a classification problem. However, I think we have not studied the decision tree till now. We have not discussed the neural network, but I'm not sure the logistic regression was there. But the logistic regression itself does the classification in a way that you have a sum score function and you try to find the softmax of those score function that gives you the maximum probability in which this class lies. Okay. So I think the option should be A. Anyone? Yeah, correct. So like when you are getting a support, when you are solving a linear classifier, you are getting the score function, right? You are getting the score. And those score can be normalized through like, okay, I will come to this later. So please remind me what I have to discuss later as well. Okay. So let's go to the next question. Then we will discuss more. So let's read it a little bit. The logistic regression framework belongs to the genre of linear classifier. That means the decision boundary can segregate class if they are linearly separable. SVM is also capable of doing so, so thus can be used instead of logistic regression classifier. Neural network research is capable of modeling linear regression, non-linear decision boundary, which linear SVM cannot model directly. Yes, so yeah, I had to tell that the neural networks are basically inherently non-linear, as well as the decision trees are also the non-linear classifier that we will see later. Find the scalar projection of B onto the vector A. So, do you remember what the dot product does? Can anyone tell what are the dot product between the two vector tails?
Yeah, absolutely. A dot B is mod A into mod B into cos theta. So
yeah,
that is a projection of one vector over the other. A projection of A vector A on B is
right.
given by mod A into mod B into cos theta. Or
Right.
you have a dot product.
Exactly. So the dot vector tells like how similar two vectors are. If you are projecting vector A onto the vector B, and let's assume that the A and the B are normalized, in that way, the projection will have the value of 1, right? I mean, A is a unit vector, B is a unit vector. And in that case, if they are laying on each other, means the dot product is 1. If they are perpendicular to each other, then dot product is 0, means they are not similar. So in this case, the projection of vector B onto on a vector A. So we have to project B onto the A. So if you will try to find the what we say, the magnitude of it, it will be like 9 and 4. We have to find the scalar projection of B onto the A. So what will the answer? So if you have to find this magnitude of A, then it will become root 5, and then you are trying to multiply it. So like
So 4 by root 5 you get. Minus 2
yes,
into 1 minus 2
yes,
by root 5 plus 3 into 2 6 by root 5 minus 2 plus
exact-
6 4 by root 5.
yeah, the option itself is not so confusing. Otherwise, we could have discussed more. Okay, for right now, we
Yeah.
will skip it.
So
Yeah.
you
But
need to normalize only vector A. That is what you are
yes,
saying.
exactly.
And take projection then.
Yes.
Is given this. No?
So
One-
for a two-class problem, what is the minimum possible number of support vectors? Assume there are more than 4 examples of each class. So, for example of each class. So, let's say you have a two-class problem and you want to create two lines which are perpendicular to each other. In that case, how much? I mean, the maximum distance can be calculated using the 2 points, right? If the 2 points lies on that line, it can be 3, it can be 4. But to create the maximum distance between two class, you need only 2 points. Am I
Yes.
correct?
Yes, one in each class. You need.
Yes, one in each class, and those points are basically the support vectors.
Yeah, support vectors. Yes.
Which of the following is a valid representation of the hinge loss of margin 1 for a two class problem? P is the predicted value of the class. So we have to maximize the value for the whatever the like the difference is. Like let's say if I am creating the margin of 1, so that is the delta. So that is 1 for all the three options, but we have to maximize it. So option B and option D are gone. Let's see option A and B. And we have to find the difference between whatever the correct is. So you can see that if you were talking there, the idea was to find the score function, and score function is basically the predicted value, right? So if you are multiplying this predicted value with whatever the output you have, in that case, your option A should be the correct. Yes. So hinge logic is meant to yield a value of 0 if the predicted output P has the same sign as the class level and satisfies the margin P greater than 1. If the sign differ, the loss is meant to increase linearly for the function of P. So basically, I discussed earlier, like when the margin is less than what we want, we are saying that the loss is 0. Otherwise, it is 1 plus Sy minus Sj. And in this case, since we have a linear classifier, this will be like whatever the predicted value you have, that is the y, that is the S itself into whatever the input you, I mean, the predicted value P into whatever the input y you already know. Okay. Now, suppose we have one feature and the binary class y, the data set consists of 3 points P1, that is x1, y1, -1, -1, P2 that is 1 1 and P3 3 1. Suppose we have one feature and the binary class y, y1, y2, y3. Which of the following is true with respect to the SVM? The maximum margin will increase if we remove the point P2 from the training set. So basically we have to find the margin, right? So if we will remove the P2, then difference between X1 and the X3 will be maximum, right? It will be 4. Otherwise it is 2. Am I correct?
Yes,
So the first option is correct. The maximum margin will increase if we will remove the P2. Yes.
Yes.
The maximum margin will increase if we will remove the P3. That is incorrect. The maximum margin will remain same because we are trying to do the binary, so we have to take any two at once. So in that case, the option A should be correct, right?
Yes.
Yeah. If we employ SVM to realize two input logic gates, so we employ SVM to realize two input. Okay, let me check who are there. So if we employ SVM to realize two input logic gates, three of the following will be true. So SVM is actually acting as a two input logic. I mean, in SVM we have the two input. The weight vector of AND gate and the OR gate will be same. What does it mean? The weight vector of AND gate and the OR gate will be same. So let's understand the question. If we employ SVM to realize two input gates, okay. So the SVM has to find either we have to go for the AND or we have to go for the OR. Okay, so our output is AND at OR. So option A is incorrect because the weight for the AND and OR will not be same because we have to differentiate them, right? The margin for AND gate and OR gate will be the same. Obviously, because we only have the two vectors, I mean two outputs. And both the margin and the weight vector. So what does mean? Okay, sorry. Option A should be correct as well because option A will be correct as well in a way that actually you have two output and you are creating the weight.
खाना करते हैं ना नहीं कर रहे थे क्या
Hello? Hello? Hello, Sandeep. Can you switch off your mic? Yeah. So basically, you have the classification problem between AND and OR. Those are the outputs. So basically, you are creating a line that is classifying that. In that case, for the classification, the weight will be same for both. What does it mean by we have two different weights? No, we have only a classification problem for basically we have a binary classification. So we will have a single weight. We will have margin, single margin, and that margin will be same because we have the only two values. So the option C should be the correct. That means both the margin and the weight vector will be same for AND gate and the OR gate, right? I'm not sure. What does it mean by weight vector? I will let's see what the explanation is. Then we will able to understand. As you can see, although the weight vector is not same, but the margin is same. I mean, the weights, okay. The point is, okay. So I have to clarify this, like when they are saying the weight vector, they are assuming that the intercept comes into the A as well. Okay. Otherwise, if the intercept doesn't come, then the weight will be same. But intercept itself, that is a B, is a part of the weight. In that case, for the different B, I can have a different margins. However, I mean, the margin will be always same. For the different B, I can have a like the greater than or less than 0 values. Okay. So yeah, so sometimes the questions are confusing. In that case, you will have to take account all the possible since they are not talking about the bias in this case, so we will have to take bias within the weight itself. Okay. In that case, the option B will be correct because margin are always fixed, so we can have a same margin. What will happen to the margin length of max margin linear SVM if one of the non-support vector training example is removed? So
Margin will
basically,
be-
they are saying that margin will remain same, right? Because they are not participating in supporting the vector, right?
Yes.
So margin will be unaltered. So this is a very simple. Yeah. So I think this is completed. Yeah. So the one thing I wanted to explain earlier was what it was. The logistic regression, right? That was the one thing. And this, not this one. This one. I think this one I wanted to explain you. So let's go here. Stop sharing. It's slow. Okay. Let me share again. In logistic regression, whatever the these S you are getting, this score function, let's say you are getting for K classes, you got this K value, okay, SK. And then what you are doing, you are trying to find the value. I mean, basically you are telling that you are modifying this such that you are getting some other value. Let's write this as a something Z1, Z2, Z3 up to Zk such that Zk is equal to e to the power sk by sum of e to the power si all, for all value of, I mean, I goes from 1 to k. Okay, 1 to k. So basically, you are just normalizing it. And since you have normalized it, this will tell about the probability distribution. Such that the sum of all z will become 1, right? and the whichever have the maximum value, that will tell that whichever z has the maximum probability, that will consider as the output of that class. Okay, and that was the score function was telling as well. Okay, so that is as simple the logistic regression. Just another simple way of telling the score function. Okay. Yeah, I think we are done for now. If you have any doubt, please let me know. Otherwise, I will try to close this class.
You can
And
share the material, course slides are
yeah,
possible.
the whatever I have taught today, right?
That one and course slides are shared.
I think yeah, it is there. Course slides are already there. I think let me show you.
Yeah.
Okay. Mm,
Excuse me, sir.
Yes.
Sir, can you please suggest that in the final exam, what type of questions it is expected to come? That will be in the same pattern that are being
Yeah,
given
generally, yes.
in
Generally,
assignments, or
yeah. Like whatever comes into the assignment in the similar fashion, you will have a questions into the final exam. So
those
I mean,
level
some
or
of the
some higher
question
level it is expected?
you
Sir,
might have
that level
some,
or any higher level questions are expected?
no, in the similar level only. Like just make sure that you don't get confused with the questions. You have
Okay.
all the assumptions in your mind and then try to solve it.
Sir,
Otherwise,
one more thing.
yes.
Sir, these tutorial classes or the problem solving classes, whatever you are covering, whether these
Yes.
questions are equally framed with similar type of weightage or whatever you have
Yes.
given in assignments?
Yes. Because whatever I showed you now, that was the previous year questions. Okay. And these
Yes, sir.
are from the same lectures, right? So it might happen that some question will be the same as well. Okay.
Okay, sir. Okay, sir.
So like, because people might become lazy to create new question and they might put the previous year questions to the final exam. That might also happen. Okay.
Okay, sir. Sir, in the upcoming tutorial sessions, also, can we expect that the similar previous year questions you will solve?
Yes, exactly. I will do that in every way.
Okay, sir. Sir, one more thing, last thing. Sir,
Yeah.
whether this video lecture, whatever you have said, the recording will be uploaded in NPTEL site?
Yes, I will upload that into the YouTube. And here you can see there is a section of problem solving session recording. When
Yes,
you will
sir.
open that, let's open here. I'm not sure what is going slow, but please wait. Okay. So you will reach to a simple spreadsheet where link of
Spreadsheet, yes,
all
sir.
that respective week YouTube videos will be there. So you can basically open that and watch whatever it was in the lecture. So you can
Okay, sir.
see.
Okay, sir. Thank you. Thank you very much, sir.
So I will upload it by tomorrow, and the link I will paste it there. So
Yes, sir. Thank you.
yeah.
Sir,
Yeah.
one question, sir. Maybe in the last, maybe in the end of the course, I'm not sure in the syllabus. So can will be doing applying any real problem, for example, right? I mean, this, whatever we are doing this, neural networks and other things, right? To pass that signal of image or a video and to classify that one, right? So is there anything in the plan, in the course, to do that? Now we are doing it's a very excellent that we are doing the actual things in the basics, but do we
Ye-
have anything in the coming in the end of the course, or
I'm not sure. I will have to check the course. But
uh,
if you want from my side to present some code and give you some glimpse of it, I can do that.
yeah. Oh, okay. So, for example, let's
Be-
suppose there is any, I mean, like if you see, right, the other things like YOLO and other things are there, right? So, I mean, they have their own things. I mean, they detect the cars, they detect something, right? But okay,
yes.
they're already made. But if you want to, by knowing this, all these fundamentals, what we are going now, right? So maybe we can take any example of one object, okay? And, we can derive that one, right? So, I mean, just want to do that one. Someone, maybe I can say that one small practical example.
Yes, yes. So since you have already discussed about it,
Yeah.
let those topics come in the later
Yeah.
weeks.
Correct.
I can give you a PyTorch code. I can basically explain you some PyTorch code.
Yeah.
I hope all of you have some Python backgrounds. So you should not have any problem reading the code. If you
Yeah.
have a problem reading the code, then I will not be able to help in that case. Otherwise,
Okay.
I can give you I can explain you some code. I can basically go through line by line and explain what the lines are doing,
Yeah.
and that might help you. I think you are discussing about this only, right?
Mm,
Right. I mean, you want some glimpse
yeah.
of the original code that should be discussed with you, right?
Okay.
So I can do that. No problem.
Sure.
Sir,
Yeah.
one
Okay.
question.
Yeah.
Can you share some reading material for this reference if there are available? Anything?
Yes. So if you have focused onto the lecture slide, there is a link of. Let me go somewhere here. I'm not sure. My computer is way too slow right now. I don't know why. Okay. Give me a minute. So there was a link of CS 231. This was one of the links cs231n.github.io,
Mm.
from where I assume the professor was taking references. So you can go there and read the same thing.
Mhm. Where is that
Uh,
link is given in the material? This one
yeah,
slides.
you can find in the reference of the material.
Mm-hmm.
Okay,
Stand
and
for. You
yes,
can
so
put
this.
that link in the chat. We can save it
Okay, I will copy this.
if possible.
And there is a professor Piyush Rai at IIT Kanpur. You can find his PPTs into the website. So
Mhm.
let me show you. I will. Okay, I will give you the link of both things. Let's see if the chat is working.
Chat is working.
Yeah, let me see. Can you see? Yeah, I have shared this link.
I have not seen. Maybe
Yeah,
chat.
so
Very chat discussion. I'm not seeing anything.
okay, I will have to enable that, but I could.
I'm not seeing because it may
Yeah, so
be.
the link is
Chat
actually
is
in the
disabled,
PDF.
sir.
Yeah, I have to enable that chat for you guys. But you can see that link into the lecture So that is cs231n.github.io.
CSV
And there is
31.
another cs231n.github.io. And there is another professor named Piyush Rai, Piyus space RAI. You can search Piyush Rai IIT Kanpur. So you will find all the lectures of Introduction to Machine Learning, Probabilistic Machine Learning, Statistical Machine Learning, and they are very detailed PDFs. You can go and read that. Okay.
Piyush Rai.
Piyush Rai. Right.
Piyush underscore Raya.
Yeah. Piyush Rai, IIT Kanpur. You can search on the. You will find the teaching material there. It is available for everyone, and you can read that.
Mhm.
Yeah.
That is one thing. What is the other thing he said? CS231.
In
CS to the
.github.io.
in
No, N like CS
N dot GitHub
.io.
dot GitHub.io.
Yes.
I'm typing right now. Let me see whether I will get or not. Yeah, I got it. Something in deep learning for computer vision.
Yes,
That's
exactly.
it.
That's
So
it.
their neural networks module 1 is there.
Yes. So you can go and try to read those. They are
Uh-huh.
exactly same in the lectures as well, with some little bit of different notations.
It's okay,
So,
but the concept will be same. No?
yes. So yeah,
So
you can read.
Piyush Roy is CSE IIT Kanpur.
Yes, he's a professor here, and his lectures are there on the internet in the PDF version. So you can read those slides.
Uh-huh.
Yeah.
Okay, great. Thank you very much.
Excuse me, sir.
Yes.
Can you tell the examples of questions asked for AIML roles?
Okay. So yeah, so you don't actually. I am from the aerospace background at IIT Kanpur. So it will be really hard for me to tell directly about the AIML roles, but I am pretty sure if you understand the basic of whatever has been being taught and you understand that and do some project, because in any role that has been open for any job, people expect you to do some project. Okay. Without project, no one takes anyone in this current AI world. So try to do some project that I would definitely, recommend you to do the project other than learning your basics. And if you are, and try to be active on LinkedIn, and there are plenty of jobs available for AIML roles. So yeah, the questions are pretty simple. Like let's say when a recruiter asks you a question, basically they watch your resume, right? And whatever you write in the resume, they try to ask from them only. And if you understand what you have written in your resume, basically you are showing your genuinity to your recruiter. And that's how people get hired, right? And genuinity comes with more knowledge, more projects. Otherwise, uh, it is really difficult because a lot of people are doing the same thing, similar things. So you will have to stand different by doing more project, understanding the basics, and be updated with the real new technologies. I'm not sure if I am uh, trying to intimidate you. I'm not sure, but this is the reality, I guess.
And sir, what is your contact like for any query?
Okay, so you can write my email. I will give my personal email. So my personal email is prashantIITK23@gmail.com. PRASHANTIITK23@gmail.com. Anything else?
No, sir.
Okay, you can write me. If I could answer your question, I will do. Otherwise, I will take that question in my mind and I will try to answer in the live lectures.
That means in IIT Kanpur 2023 you are there since I.
Yeah, January 23, yes.
Mhm.
Basically, I'm a fourth year PhD student. Yeah.
Pardon?
Basically, I am fourth year PhD student in Department of Aerospace.
So you're doing now in the 4th year PhD.
Yes.
So how many more years it will take for PhD to be completed?
I think my PhD is almost finished. Let me not record these things. Yeah. So my PhD is almost